I'm Tim Ventura, and we're joined today by Dr. Beatriz Villarroel, an astronomer at the Nordic Institute for Theoretical Physics in Stockholm. Dr. Villarroel has a master's in physics and PhD in astronomy from Uppsala University, along with numerous professional awards and honors, and a collection of peer-reviewed papers in prestigious journals, including the Astronomical Journal, the Astrophysical Journal, Nature Physics, Acta Astronautica, and the Nature Journal. Dr. Villarroel is also the project leader of the Vanishing and Appearing Sources during a Century of Observations, or the VASCO project, along with founder of the EXOPROBE project, aiming to find an extraterrestrial probe in the solar system, which are topics that we will be discussing today. So Beatriz, welcome. It is a pleasure and an honor to have you with me today, ma'am.
And thank you so much. I'm looking forward to the conversation.
So I want to focus on the big picture view of humanity's place in the cosmos, which is exactly what you are doing at the VASCO and EXOPROBE projects. This is, for me, this is one of the things that I'm most excited about, is where the human race is going and where we fit in the universe. Again, this is what you do. So let me start by asking for a quick overview of what these two projects are, VASCO and EXOPROBE, and what inspired you to get involved with them.
So the VASCO project is something that I started in 2016 when I was I was a PhD student, and I was very obsessed by this thing, like, could a star vanish? Had anyone ever searched for vanishing stars? Because we know that these are processes. If a star dies, it will take you billions of years until it turns into a white dwarf, or it will be a very long process until it blows up into a supernova. But could a star just vanish? Had anyone ever looked for them? And could this be somehow related to technosignatures, or to, let's call it, engineering by some very advanced civilization, or maybe even some fundamental physics ideas that we haven't thought about yet? So this was a thought that I got in 2016, or actually I got it much earlier, like years earlier, but in 2016, I could finally check that. And I was acquainted with the US Naval Observatory's catalog, and that was constructed by an astronomer called Dave Monet. And this catalog was based on images from the 1950s. And I said, oh, wow, if there are images from 1950s, that means I could compare the sky as it looked back then, to the sky as it looks today. And I went there and used the Sloan Digital Sky Survey and compared for the first time, like, parts of the sky, maybe 1% of all the data from the US Naval Observatory catalog with the data that I had at hand back then. And this is how the project was born, the VASCO project, through these searches. And I found mysterious objects in the 50s that I couldn't find later, and some kind of very short-lived objects that you only see in one image and that you never found again. Vanishing stars, people like to call them. I was hoping to find a real vanishing star, something where you saw it in 100 images and later it vanished. But instead I found these very short-lived things. And that's how it all started. In 2020, we published, actually it was in the late 2019, we published a paper where we had looked through like 15% of the database we had constructed based on these catalogs from US Navy and Pan-STARRS, the most modern thing we had. And we found these like we found lots of these transients where you saw something in one image but never again. And even weirder, we found something where you saw several of them, like 9 objects in one image from the 50s that you never found again. And that created a mystery, which led us to the EXOPROBE. Because one of the possible explanations we had for that is that you can create kind of these effects where you see multiple objects appearing and vanishing in a small image in a small part of the sky in a short time, if you have something artificial that is reflecting the sunlight, for example, like satellites or space debris. And what was then the thought? Well, maybe what we see could be that. except for that this are images from 1950, 7 years before Sputnik 1. And of course, that is an exciting problem then. We published a paper in 2021 showing these 9 transients, and we found more examples since then. And we wonder, is this real or is it not real? And I think there's a very big possibility that this is real, but to confirm it, we created the EXOPROBE project that aims to search for these kind of events, but also to search for concretely for signatures caused by an extraterrestrial probe. And that is how the EXOPROBE was invented, simply that we need to confirm this in today's sky. Because if you look back at something 70 years ago, you can never trace that object again. But if you can confirm it in today's sky with a completely new instrumentation like we use for EXOPROBE, where you search for these objects specifically and for their signatures, then what happens is that you can reproduce the finding. You can verify it directly. And you can learn something about the object. You can localize it. And once you have all this information, if you're lucky with it, your scientist colleagues can do the same. There will not be any more question marks. You want something where you can simply say, this is an extraterrestrial probe, it's real, everyone in the world can look at it and confirm that it's extraterrestrial. That is what I would like to achieve. And that is how we created the EXOPROBE project that I can tell you later more about if you want.
Oh, absolutely. Well, before we get deeper into VASCO and EXOPROBE, though, I want to talk about SETI. And again, this goes back to kind of the big picture motivation, the thing for me that gets me so incredibly excited about this. So in terms of SETI, Frank Drake estimated that there are around 10,000 advanced civilizations capable of radio transmissions in the Milky Way galaxy. But for each of those civilizations, there are potentially millions of planets with simple life, and some or many of these planets will probably have ruins of past civilizations, right? Because these civilizations have a life expectancy. So presumably they come and they go and they leave behind remnants, and they probably leave behind probes, right? As they expand, just as the human race is. Right now, we have probes, of one type or another at many of the planets in the solar system. We have rovers all over Mars. If, God forbid, something happens to the human race, those will still be there, right? And so I think one of the aspects of VASCO that is so exciting is looking for these not only existing civilizations, but remnants of past civilizations, potentially alien megastructures. There are so many things that could be out there, and the statistics seem to indicate that they are, right?
Well, I see it slightly differently. I agree with you entirely on like this absolute magnificent thing if we could find a relic from a past civilization. Now, let's say that we actually confirm that whatever we saw in the photographic plates were real objects. These objects could have been there for maybe 100 millions of years and stayed in high orbits around the Earth and just orbited, and then we would see something that a past civilization placed there, whether it is a past civilization on Earth or, well, I don't think it is, but, or a past civilization, alien civilization that sends something to us. And there are also other ways how you could, for example, detect them. I don't know if you heard about the Clark exobelts, and that it's an idea by someone you might want to interview at some point is Hector Socas Navarro at the IAC in Spain, who had this idea of that you could look for a civilization that has left a thick belt of satellites and space debris, and you can look for it in transits of other stars. And so let's say you have a civilization that left lots and lots of space debris in their planetary system, and you maybe could see it from here. And maybe that civilization would be dead, but their space junk is still there. And that is fascinating to imagine. And well, I know Dyson spheres have been looked for, but so far one has scored like hundreds of thousands of stars and one hasn't found anything. So I think these objects are very difficult to build. It's much probably easier to just create a lot of space junk in orbit. While Dyson spheres, well, I'm a little bit skeptical about them, but yes, theoretically, VASCO could be detecting a Dyson sphere that is built very fast and is very, very powerful. But if a Dyson sphere would be very slowly built and only make small changes in the magnitude, then VASCO probably isn't specially designed for that. We could see it if we wanted, but we have more focused on searching for things that really vanish rather than look for things that really fade. However, there are other projects like where they base searches for fading objects on, let's say, test data that are being done. But VASCO is more interested in more extreme things.
Well, I want to get more into the likelihood of extraterrestrial life. I recently interviewed Dr. Robert Zubrin, and he pointed out that hydrogen, helium, oxygen, and carbon are the four most plentiful elements in the universe. So not only are there potentially millions of planets with life, but it's also likely that it evolved in a chemical environment similar to ours. And I want to touch on a talk that you gave at TEDx Zurich, and I used that to write a lot of these questions. It was a wonderful talk. I will put links into the show notes for that. You talked about the VASCO project, mentioned that there are 40 billion Earth-sized planets in the Milky Way galaxy. Scientists have already found over 80 different types of amino acids on asteroids, even the building blocks of DNA. So in terms of the number of planets out there that could potentially harbor life, as well as the chemistry that's involved to create life as we know it, there's a lot to support this idea that underlies the VASCO project, right?
Absolutely. I wouldn't be doing it unless I believe that there are all the conditions for life to be plentiful. That's my point of view, because I mean, like you said, these four elements are simply the building blocks of organic chemistry. And I think that's why it's likely that you're going to have the same chemistry of life everywhere throughout the galaxy and throughout the universe. And also you can have, let's say, some kind of cosmic panspermia where you have simple, well, either simple organic molecules or actually microorganisms coming from one planet to another with help of simply you have some meteorite that hits into the Earth or so. I think these things are going to make our galaxy flourish with life. And once you have lots of life, you can also form advanced civilizations. You just need enough of time. You need a stable environment. For example, you don't want to live close to a quasar or a blazar that is shooting a radio jet on your planet all the time. You don't want to live close to a flaring M dwarf, but you want to be in places where life can evolve during millions of years or hundreds of millions of years and without having any major dramas that would wipe it out. Of course, we should be happy that there was a major drama that we don't have the dinosaurs here now, but still, I think there's amazing possibilities to have so many advanced civilizations just in the Milky Way. So let's look for them.
Yeah. So VASCO is a form of what has been described as optical SETI. I wanted to kind of get that term out there. And I love that term. I'm a giant fan of SETI in general. Optical SETI seems like a way to differentiate that. Instead of looking at radio signatures, again, you are looking mostly at optical photography. I wanted to ask, do you use like computer analysis to compare these photos? It seems like that would be far too intense to try and do by hand, right?
We have done everything. When I did it first or the first VASCO paper for 2020, I had to look through something like 23,000 objects or 24,000 objects, which means about twice or 2.5 times the number of images. I did it alone during 3 months, lots of chocolate, lost 1 dioptry in the eyes. And but later, we started a citizen science project, and we are that is open for the public, and we have worked a lot with scientists globally in order to search for these vanishing stars. And there we were looking through our set of candidates that was based on this US Naval Observatory catalog. And so the citizen science project has been running for several years and is being in the stage of analysis of the candidates now. But we have also, with the help of the Spanish Virtual Observatory, done an automated process to search for these vanishing stars. And there's a paper by Enrique Solano and myself and Carlos Rodrigo, where we have done this automated analysis from last year. We have tried all methods to just crunch the data and see what we can find.
Well, and so in addition to looking through the past historical records, you're also developing new instrumentation. I wanted to ask about that as well. How would that work? What would that look like?
So this is what we do in the EXOPROBE project. And we are interested in finding any fast flash that can be associated with either a solar reflection, because when you have something tumbling in space and it sometimes reflects the sunlight, you can get a fast flash just from this glint. Or like in Swedish, we call it solkatt, solar cat sometimes. And or just some kind of fast flash related to emission, let's say a UFO blinking, either a laser or just blinking. And so the idea is that we can look outside the Earth for these kind of unidentified objects. Forget about everything inside the atmosphere, because once you're inside the atmosphere, you have all the stuff that you have so many false positives that it's a nightmare to go through that. But we want to look for these very specific signatures of unidentified objects, non-human objects. And the idea is that you have a network of telescopes. So you need at least 3 of them, but imagine now this network of telescopes that are watching the same part of the sky, and now they happen to see this flash from an unidentified object. Once you see this flash in more than one telescope, you say, because if you only see it in one telescope, you can say, okay, maybe something is wrong with the optics. Maybe this was a cosmic ray. Maybe it was a bird that blinked, or I don't know, birds don't blink, but well, you get the idea. That can be
I was thinking of iridium flares, right? Flares off satellite antennas and things like that.
We can check all that, and we can get rid of those things too, because we have a filtering methods. But the idea is simply that you need to verify the flash that we get, that you see, or glint, or whatever. You need to verify it in multiple telescopes. When you verify it in multiple telescopes, A, you know it's real, a real observation, and B, you can localize it. And C, we have developed a method that I cannot talk about yet to get rid of all these iridium flares, to get rid of basically anything, all the space debris, and to be able to separate human satellites from ET probes. So we have been working on that, and we're still working on developing it further. And now you're at the stage where you have verified an object. You have said that this is probably not human, most likely not human. And you have also localized it in 3 dimensions. And the more telescopes you have, the more carefully you localize it. And that's when you also, at the same time, in real time, will take a spectrum, because the spectrum will tell you if it's an emission or if it's a solar reflection that you see. And you can learn a lot from the spectrum about the object. And once you have all this set of information, well, that's Christmas time for scientists, especially if it's an ET probe. And that's the idea we have.
Let me apologize for jumping in, but if you can do the spectrum on it, could you also determine redshift or blue shift to tell how fast it might be going?
Probably yes, to some extent. You could, if there is some shift, you would see it. Maybe there is no shift at all. And it depends on how much it is. I would have to calculate it, I guess. Well, so it depends. I think that, for example, this is most likely just going to be a solar reflection you're going to get, where you're going to get the spectrum of the sun. If it's an object that is just in orbit, you're not going to see
it wouldn't be moving fast enough for that.
Exactly.
I was wondering about the Oumuamua and objects like that, these Avi Loeb's interstellar object, right? And I think even that probably isn't moving fast enough for a redshift or blue shift. But
I think if you imagine a quasar in Halton Arp's universe that is flying very, very fast to watch us, maybe you will see something. But not.
Well, let me jump into a quote by Carl Sagan that you talked about at TEDx Zurich. When I heard this, I got so excited. So you cited an estimate by Carl Sagan that the Earth may have been visited 10,000 times by ET passing by at nearly the speed of light. And you have mentioned that there may be millions, maybe billions of space probes out there just flying around, and that we might detect them in optical observations. So do you think that Avi Loeb's Oumuamua interstellar object would be an example of something like this?
It's an example of something very interesting, but it could also be a new type of um, comet or a new type of asteroid that I don't know about. So I'm kind of agnostic about it. It could be either way. And that's why I think it's so important to examine that type of objects like Avi is doing. So I think it's the correct direction to go, because I know a lot of astronomers just dismiss it, but maybe they also know much more about solar system objects than I do. But it is a possibility, and I would search more for these objects, and I would try to understand them better.
Well, you also were talking at TEDx Zurich about biological gases and exoplanets. And I think that this is also something that is very exciting. I have seen other people speak about this. And from what I understand, that is still very difficult to detect. That's just starting to become an aspect of research. But if I understand correctly, it may be possible to detect signs of life by looking at the atmospheres of other Earth-sized planets, right?
I think it's going to be a long time before we can do that in a serious way, because trying to get the spectrum of an Earth-sized planet is like trying to get the spectrum of a firefly next to an atomic bomb explosion. So it's very challenging. And even if you would finally get it, there's still going to be a lot of ambiguity in interpreting that spectral line, if it's like formed by life or some weird processes, some volcanic processes. We saw the whole life on Venus story, and that's a planet in our solar system that is so difficult. I mean, even there's a lot of ambiguity. Now imagine from a star, like from another star, and moreover that you have so weak signals. I think this is going to be decades before we are there. I guess in 50 years. I might be wrong. I'm very negative.
If I could ask, when you were going through, again, in VASCO, you were looking at a countless number of old photographs. And, and then EXOPROBE, you guys are looking for, I guess you might almost call it tight beam laser transmissions, right? When you're
Also, not only.
Okay. When you were looking through these, how do you visualize what you might find? You'd mentioned alien probes. What comes to mind, I guess, when you were doing the work? Are you talking about just like a spacecraft, like a rocket type object, or?
Imagine what came to my mind when I was doing the VASCO work. Let's say ET sent something 200,000 years ago and forgot a can of Coca-Cola in space or something similar. And that thing stays there in orbit forever. And at some point we see these little glints. It might be a completely useless object. Maybe not even a probe, but a remains or just an artifact of ET. That's what I had in mind when I was suggesting that we should actually score all these photographic plate surveys for ET probes.
Okay, I understand what you're saying.
And
So
artifacts.
it could be anything. It could be anything, right? And
Exactly.
yeah. Now, if it's okay, I do want to ask about the Seoul Foundation conference. You just spoke there. They were involved with UAP. That was something that they were focused on. And in the TEDx Zurich conference, it seemed like that was not a giant focus area for you. Is it okay to ask what your thoughts are on the UAP phenomena?
Well, I find it absolutely important to test whether the UAP phenomena can be linked to some kind of ET probes, because this is a very concrete hypothesis we can work with. There are other ideas related to UAPs that I'm not going to dive into, but for me as an astronomer, it's an exciting possibility, because if ET actually would be sending probes, maybe even some advanced spaceships, because if they are much more advanced than us, maybe they have ways of entering the atmosphere and leaving. And now imagine ET has done that. Why wouldn't we mistake it with a UAP? I mean, why wouldn't it be so that some of the UFOs we see are actually alien probes or alien spaceships? I find it fully reasonable. So that's my interest, is in trying to confirm or test whether there are ET probes or spaceships in the solar system. And if I get the answer yes, then I'm going to be a complete believer into UAPs. So far, I'm agnostic.
For me, these ideas of SETI, VASCO, Oumuamua, Tabby Star, even the UAP phenomena, they hint at a paradigm change in science towards the acceptance of humanity's place in a much larger tapestry of galactic life. And I'm wondering if maybe that isn't the larger change, is that we are seeing a social and scientific embrace of these possibilities that didn't exist in the past. Is that something that you would agree with, something that you've seen?
I think that is true. And something that I also seen is true is I think this the whole discussion about UAPs is so extremely important, because Radio SETI has not really succeeded with finding any candidates. So we need a new parameter space where people can actually do reasonable searches for ET. And so far, like until the last years, it was very taboo to search in the like close to the Earth, because it was so associated with the UFOs, and people were like, oh my God, UFOs, that's so bad. That's some big crackpot stuff, you know. And now it isn't that way, because thanks to the destigmatization of the UAPs, we have opened up a complete new parameter space of searching close to the Earth and even inside the atmosphere. And we know that it's reasonable that someone could send something nearby the Earth. So why haven't we been able to search for it before? The stigma has really disturbed a large part of the scientific possibilities, and the stigma is vanishing. I think it's fantastic. It opens a new port for the searches, or a new door for the searches for ET. I'm very much looking forward. And this, by the way, the Sol conference I was on was amazing. It was something really, really spectacular, I can say.
Wonderful. Well, Beatriz, let me thank you so much for your time today. It has been a pleasure and an honor to have you with me. I would love to have you back again in the future. We can talk more about VASCO and EXOPROBE, and of course about Drake and SETI and all of those exciting topics. Let me close by asking, what is coming next for you in the next few months, and what do you see happening in the optical SETI world? Do you have any short-term predictions for VASCO or EXOPROBE?
So I'm going to be an optimist when I reply this question. And the first thing in the near future for me is, of course, that we are going to be wrapping up the results of the Citizen Science Project of its first phase, but also to really get all the instruments in place for the EXOPROBE, because we are still in the stage when we need to place telescopes and like start up everything. It's a very, very fresh project that's just started a few months ago. So that is what is in the close future for us. And of course, I'm optimistic. I'm hoping that we will succeed finding these exciting signatures in the EXOPROBE project, and to confirm what we believe we have seen in the VASCO project. So I'm hoping for all that. And I think that the coming years are going to be extremely exciting, mostly thanks to that UAPs are now a valid research topic. And there's so much to discover there.
Beatriz, let me thank you again so much for your time today, ma'am.
My pleasure.